Hello and welcome to today's video. So in today's lesson, we're going to learn how to determine the number of electrons when we are given a set of quantum numbers. Let's quickly dive into it. So when we are asked to determine the number of electrons, for example, find the maximum number of electrons that can be found in the energy level 5. So how do we go about it? So the first thing we have to know is we have to know the energy level. We have to understand the sub-level for us to determine the maximum number of electrons. So when n is equal to 1, it means that we are looking at 1s, and we understand that s occupies the maximum of 2 electrons. When n is equal to 2, it means we have 2s and 2p. P accommodates the maximum of 6, so this is 2, 6, which gives us 8 electrons. When n is equal to 3, we're looking at 3s, 3p, and 3d, where we know that d accommodates the maximum of 10. So this would be 2, 6, 10, giving us a total of 18. What about when n is equal to 4? So this would be 4s, 4p, 4d, 4f. So this would be 2, 6, 10. So here you can notice that there is a sequence of 4. There's an addition of 4. Therefore f will be 14. So 14 gives you a total of 32. So what is the relationship here? So the relationship is that we can find the number or the maximum number of electrons using this formula, where n represents the energy level. So in a case where n is equal to 5, we can say 2n squared, 5 squared, which is 225, then gives us 50. Meaning, when n is equal to 5, we have 5s, 5p, 5d, 5f, and 5h. So, following the sequence of an addition of 4, this becomes 18. So this would be 2, 6, 10, 14, 18, which should give us a total of 50 electrons. So the easiest way is when we're asked to find the number or the maximum number of electrons to be occupied when n is equal to 7, we just say 2n squared. It's 2, 7 squared. So it's 2, 7 by 7, 2, 49. Then the total is 18 electrons. Now, let's look at an example of where we have different quantum numbers involved. So, example, say find the maximum number of electrons in the following. When we are given a set of quantum numbers, for example, question 1, when n is equal to 4, then ms is equal to positive half. So using the previous formula, 2n squared, I can just say 2, 4 squared, that'll give me 32 electrons. So this is the maximum number of electrons. Now, if I look at the requirement, is that those electrons are supposed to be upward direction or upward spin direction. So meaning from there, we know that there can only be 2 directions. It's either it's a positive or a negative. So it means half of these electrons, 16, are the ones satisfying the given condition. Visually, what we can look at is that we have the n, which is 4, meaning that my L is less than or equal to n minus 1, meaning my L is less than or equal to 3. So when I have this, it means I have 0, 1, 2. Then I know this is S, this is P, this is D, this is F. So looking at it visually, I have the 4S, I have the 4P, I have the 4D, and I have the 4F. Then from the ML perspective, this is 1, this is 1, 2, 3, this is 0, negative 1, 0, 1. This is 1, 2, 3, 4, 5, which is negative 2, negative 1, 0, 1, 2. Then this is 1, 2, 3, 4, 5, 6, 7, negative 3, negative 2, negative 1, 0, 1, 2, 3. So if I allocate the number of electrons in all these, so a pair is up spin, down spin, up spin, down spin. So to have a visual representation of what we are doing, here we're saying now we can focus on those that are in a positive. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Therefore, my number of the maximum electrons is 16. We can look at another example. Example 2. What if we're given principal quantum number 4, then L is 2, then we are asked to find the maximum number of electron. So the same principle, we have the 4s, the 4p, the 4d, and the 4f. But in this case, we are focusing much on the when L is equal to 2. So what is the condition? So when L is equal to 1, this is S. When L is equal to 2, this is P. When L is equal to 3, that is D. Sorry, 0, 1, 2. When L is equal to 3, that is F. So they are focusing on the D. So how do we go about it? So we know that according to ML, this is 1, 0, 1, 2, 3, negative 1, 0, 1, 1, 2, 3, 4, 5, negative 2, negative 1, 0, 1, 2. So because they're focusing much on the D, so we are here on the D. How many electrons are there in the D? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, the number of electrons is 10. That's the maximum number of electrons that will satisfy the given condition. Let's look at another example. Example 3. When n is equal to 4, ml is equal to 1. What is the maximum number of electrons? So this is 4s, 4p, 4d, 4f. Then when we come to the ml, this will be 0, 1, 2, 3, negative 1, 0, 1, 1, 2, 3, 4, 5, negative 2, negative 1, 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, negative 3, negative 2, negative 1, 0, 1, 2, 3. So which ones will satisfy the ml? So when ml is equal to 1. So when ml is equal to 1, we are looking at here, here, and here. And when we put the number of electrons there, we'll realize that it's only 6 electrons that will satisfy that given condition. Let's look at the fourth one. Fourth example. When n is equal to 4, then L is equal to 3, then ML is equal to -1. So we have 3 given conditions. So what electrons will satisfy, what is the maximum number of electrons that will satisfy this particular condition? So we have 4s, 4p, 4d, and 4f. Then remember, here they're interested in when L is equal to 3. So when L is equal to 0, it's S. When L is equal to 1, it's P. When L is equal to 2, it's D. When L is equal to 3, it's F. So they're interested in the F orbitals, which is 1, 2, 3, 4, 5, 6, 7. So when we allocate those electrons, the question is which electrons are satisfying this given condition. So this is -3, -2, -1, 0, 1, 2, 3. So we realize that it's only this part, that is when the ML is equal to -1. So it's only 2 electrons. That's the number of electrons that will satisfy this condition. What of a situation where let's look at, this was question what? Question 4. Let's look at question 5. 3, 4. Okay, let's look at question 5. So question 5, when we're given this and ML is 1, so what will be the electrons that will satisfy this condition? So again, this is 4s, 4p, 4d, 4f. So when ML is 1, so this is 0, 1, 2, 3, -1, 0, 1. This is 1, 2, 3, 4, 5, -2, -3, -1, 0, 1, 1, 2, 3, 4, 5, 2, then 1, 2, 3, 4, 5, 6, 7, -3, -2, -1, 0, 1, 2, 3. Then here we are only limited to those ones +1. So when we put the number of electrons in there, we'll notice that the maximum number of electrons that can satisfy that condition are just 6 electrons. Let's look at another question. Question 6. What if we're given when n is equal to 3, L is equal to 1, then ms is equal to negative spin. So we know that L is less or equal to n minus 1, therefore L is equal to so which means you have 0, 0, 1, 2. Okay, so in this case we are looking at the 3s, the 3p, and the 3d. So we have 1, then 1, 2, 3, then 1, 2, 3, 4, 5. -1, 0, 1, 0, -2, -1, 0, 1, 2. So we are interested in L is equal to 1. When L is equal to 0, it's S. When L is equal to 1, it's P. When L is equal to 2, it's D. So we are interested in when L is equal to P. So when we put the electrons there, 1, 2, 1, 2, 1, 2, then the other condition is which electrons are undergoing a down spin direction. So when we check there for the down spin It's only 3 electrons. This one, this one, this one. Therefore, the number of electrons here will be 3. Alright, see you in the next video.